angles, all right? We've talked about angles. We've got obtuse angles, we've got acute angles, and we've got right angles, okay? So the triangles are classified the same way, okay? So, actually, let's think about this. What do you think this first one is?
Right.
Yeah, we definitely have a right angle here, so this would be a right triangle, okay? And the next one,
Equivalent, or whatever.
oh, yes, but that's by length. So don't write that down. We're classifying by angle. Yes, acute. This is an acute triangle. And the last one, all you need is one angle bigger than 90, and that would be this angle right here is bigger than 90 to make it an obtuse triangle. So for acute, all three angles have to be less than 90. And for an obtuse triangle, you only need one angle greater than 90. So you guys, this should be in your notes in case you do a notebook check, right? Make sure you have all the pictures and a label for each type of triangle. Okay, now we're going to classify by length, which some of you guys were already talking about. So the little checky mark things, I don't know what you call these flash mark things. Anybody know what those mean? Jacob?
So like if there's one on one side and then there's one on another side, it means that they're equal to each other?
Yep. So this one, because they each have one hash mark, means they're all equal. All right? All the lengths are equal. This one, we've got two equal lengths, but this one down here is different. And then the first one, we have all different lengths. Okay? Can anyone tell me any one of the names of these? Evie. Very good. This last one is equilateral. Okay, which means that all sides are the same length. Isaac?
Middle one is isosceles.
Yep. Good. Thomas?
First one, scalene.
Very good. Scalene might be a new one for you guys. Okay, if they're all different lengths, it's called a scalene triangle. If two are the same, it's isosceles, and if three are the same, it's equilateral. Now, technically, this last triangle can also be called isosceles because it's got at least two sides the same. Okay, so if at least two sides are the same, it's isosceles. So the last one is both isosceles and equilateral. There's another name we have for equilateral. Isaac?
Well, I have a question. If you're like in the equilateral triangle, do you have to put isosceles?
No, I think I'll just have you put equilateral. Yeah, but I just want you to know. Yep. Okay. Also, if these are all the same right here, it is also equiangular. And if it's both equiangular and equilateral, or equal, yeah, it's called regular. All right. There's a lot of words for that guy. Pretty special triangle right there. But the one that I'm looking for when classifying by length is this one. Okay. All right, this is very important. The sum of the angles inside of any triangle, the sum of the three angles, anybody know what it always is? Coleman? Nope. 180. All right. 180 degrees. Write that down. The sum of all the angles inside the triangle, and they always add to 180 degrees. That's something you want to memorize. So we've got a triangle down here, and angle Y is 30 degrees, and angle Z is marked with that little box, so it's 90 degrees. So what would we do to find angle Z? Hannah?
You would add angle x and y and then subtract.
Yes. Anybody know an equation we could write? Harrison?
120 minus, we're supposed to be equals.
Yep. Only do it like this. But yes. Okay. So what I want to see is the sum of those three angles. So 30 plus 90 plus z equals 180. So 30 and 90 is 120. And to solve, we subtract 120 from both sides. So the missing angle is 60, and be sure you have a degree symbol on your answer. Okay? So write an equation, and some of them always add 180, and solve. So let's try another one. Find angle A. So Anna, what equation would you write down to find angle A?
40 plus 50 plus A equals 180.
Nice. Good. All right, so then 40 plus 50 is 90. And to solve, Chris, what algebra step would I do? Yep. And so A is equal to 90 degrees. Okay, classify angle P or triangle PQR by its sides and by its angles. Yep. So two names for this triangle. Mark, what do you think?
The right triangle and a scalene triangle.
Good. So when you classify by angles, it's a right triangle because we've got the one right angle. And we've got 3 different lengths, which means it is scalene. Make sense? Let's try another one. If you don't write all these down, it'll be fine. Okay. Angle M is a 50-degree angle. Find the measures of D and E. Actually, do write this one down. This one's important. Sorry. Okay, so angle M is 50 degrees. When it tells you an angle, you might want to just put it in the drawing. It helps. Okay. What kind of triangle is this? Isosceles. So there's a really cool thing about isosceles triangles. They have 2 sides the same, and what else do they have? Yes. If these 2 sides are the same here, the 2 base angles are also the same. So who could write an equation for me? You have to be a little creative. Thomas?
50 plus D plus P equals 180.
Okay. And what do we know about D and E? They're the same. So could we just say the same like D and D? Use one variable, right? Because they're equal to each other. So now I can add D plus D. What is D plus D? That'd be D times D, right? D squared. D plus D would be 2D. Okay, then subtract 50 from both sides. So what do I get? Good. Then divide both by 2, because we have to divide those angles there by 2, and they are equal. And so D is equal to 65, and E is equal to 65. Okay? So if it's isosceles, use the same variable when you add. You get 2 of them, and then you divide by 2, so you can find that missing angle.